Recording started.
Hello, welcome to this session on solving equations. We are going to be using the properties of equality to solve equations, and we will write and solve equations to model real-world problems. So the first equation we're going to look at is 7x plus 2 equal to negative 54, and we need to solve this equation. This is a multi-step equation because it has two operations occurring on the left. We have multiplication between the 7 and the x, and then we have a 2 being added to the x. So when we are solving this, we're going to use the reverse of the order of operations. So we're going to start with undoing any addition or subtraction first. So we're going to subtract the 2 to the other side. When we subtract the 2, we get 7x equal to negative 56. Now we'll undo the multiplication that's being done to x by the 7 by dividing both sides by 7. So x is equal to negative 8. You should always check your work. I'm just going to check this first problem. But whenever you do a solving equation problem, you want to check your answer to make sure that it's correct. So we're going to take negative 8 and we're going to substitute it back into the equation for x. So we're going to replace the x with negative 8 plus 2 equal to negative 54. And we want to make sure that we write it as a multiplication because the 7 is multiplying the x, so therefore it is multiplying the negative 8. So we get 7 times negative 8 is negative 56 plus 2, and we want to know if that equals negative 54. Negative 56 plus 2 is negative 54, and that is what this problem is equal to. So we know that this solution checks, and so x equal to negative 8 is the correct answer. You can pause this video or recording if you need extra time in the lower left-hand corner. Solve negative x minus 2 equal to 3x plus 5. So now we're getting problems that are a little more complicated because notice we have a variable on both sides. So what we have to do is, our goal is to have the variables on one side together and then the numbers on the other side together. So we want to collect like terms on one side. Most of the time students like to take the variables to the left side and have the variables on the left and the numbers on the right. So you can do it either way, but I'm going to focus on these remaining problems doing it that way, with taking the variables to the left side. So remember, when we take something across the equal sign, we want to do the opposite. And I can start with taking the 3x over first. I'm going to take the variable over first, and since it is a positive 3x, I'm going to subtract it to the other side. And I'm going to be subtracting it from the negative x. Now remember that that negative x does have a 1 in front of it. Remember, when you have a variable and you don't have a number in front of it, there is a 1. So it's negative 1x. So it's negative 1x minus 3x, and that will give me negative 4x. My minus 2 is still there. The 3x minus 3x cancels, and that's equal to 5. So now it looks like the last problem that we did, where we take care of the addition or subtraction first. I'm doing that. So I'm going to add 2 to both sides. The 2 is being subtracted, so I'm going to add it to the other side. So I'll have negative 4x left remaining on the left side, and I'll have 5 plus 2 gives me 7 on the right. Now I'll divide both sides by negative 4. And I get x equal to, remember the negative 4's will cancel, I get x equal to 7 divided by negative 4, or negative 7/4. You can change that to an improper, you can change that from an improper fraction to a mixed number if you would like, but you can leave it in this form. So our answer is negative 7/4. Next we have solve 11 plus 3x minus 7 equal to 6x plus 5 minus 3x. So our problems are getting a little bit more complicated as we go. If you notice on the right and the left we have variables and numbers. We can do some combining here to make this problem a little bit easier to work with. I can combine the 11 and the negative 7 or minus 7 together to give me a 4. And I'll have 4 plus 3x. On the right side, I can combine the 6x and the minus 3x, because they're like terms, to give me a positive 3x plus 5. And I can do that by the commutative property. So now, I'm going to work on bringing my variables to the one side. So I'm going to subtract 3x from both sides. So what I have left is 4. 3x minus 3x is actually 0. So I end up with 4 plus 0 equal to 3x minus 3x is 0 plus 5, and I end up with 4 equal to 5. That's not a true statement. So what happened here, when your variables cancel out like that on both sides, we get a no solution. So when you're left with two numbers that are not equal to each other, it's called a no solution. And you may see it written as an empty set. This is called an empty set with the circle or the 0 with the line through it. Empty set or no solution. So that will happen in the problems that you're working on, and you will see those as you work through your lesson. 6x plus 5 minus 2x equal to 4 plus 4x plus 1. This is very similar to the last problem. I'm going to work on combining the like terms before I go any further with solving. So I'm going to put the 6x and combine it with the minus 2x. So very important, guys. Signs are going to be very, very important here. You really want to be careful. Make sure you pay attention to what sign is in front of the number, because that is the sign of the number. So if we look over here, this is a positive 4 and a positive 1. I can combine those together to give me a 5. And if you notice what we have here, we have 4x plus 5 equal to 5 plus 4x. Well, the left side is saying the same as the right. So when that happens, when you have the same thing on both sides, that means any value for x that you put in here will work in this equation. So that we say that we have a solution of all real numbers. So our solution is all real numbers, and your lesson, or you may see it designated with the R. Now, if you were to continue solving this, I would just want to show you, if you continue solving it, if I take the 4x to the other side, if I subtract 4x to the other side, I will get 0 plus 5 equal to 5 plus 0, and I get 5 equal to 5. So this time I get two numbers that are equal to each other. My variables have canceled out, but I get two numbers that are equal to each other. So the two different situations that you're going to see, well, one of the three situations, you will either have a solution like we did here. You will either have no solution, where you get two numbers that are not equal to each other at the end and the variables have canceled out. Or you'll get a solution of all real numbers, where the variables cancel out, but you're left with two numbers that are the same. Let's do one more problem together. This one uses the distributive property because you have a 7 outside the parentheses and a 6. And if you look inside the parentheses, there isn't anything that can be combined in either of these parentheses, because 5x and 2 are not like terms. So I'm going to multiply the 7 through the parentheses using the distributive property. So it'll be 7 times 5x plus 7 times negative 2 equal to 6 times 6x plus 6 times negative 1. So now 7 times 5x gives me 35x. 7 times negative 2 will give me a minus 14. 6 times 6x will give me 36x. And 6 times negative 1 will give me a minus 6. So I'm going to continue solving here by subtracting the 36x from both sides. 35x minus 36x will give me a negative 1x, or a negative x. 36 minus 36x is 0, and I have the minus 6. Again, really be careful about the sign. I have to bring that minus down because it makes the 6 negative. I had to bring this minus down because it makes the 14 negative. So I'm going to finish the problem. This is like our first problem, where I'm going to add 14 to both sides. I want the numbers on one side, variables on the other. And that will give me negative 1x equal to 8. And if you recall, you cannot have a negative 1 in front of your variable at the end. So that negative 1 is multiplying the x, so I'm going to divide it on both sides. And basically that just changes the sign of your answer. So we get x equal to negative 8. 8 divided by negative 1 gives me a negative 8. So moving on to our last couple of problems here. These are actually some directions for word problems that you want to take note of. When you have to do a word problem, define a variable for the unknown number. So first figure out, what am I trying to find in this problem? Make that your variable. Then write an equation to model the problem, solve the equation, and then check your answer. So the problem that we're looking at is Mrs. Jenkins decides to join a shopping club to buy supplies for her convenience store. On her first visit, she buys the $55 membership and several cases of soda for $7.50 each. The total for her first visit is exactly $100. There is no tax on the soda. How many cases of soda did she buy? So we're looking at, what are they asking us to find here? Well, what they're asking us to find is how many cases of soda. So I'm going to use x as my variable, and x is going to represent the number of cases of soda. So sometimes it helps when you're trying to do a word problem if you think about it in terms of numbers. So let's say that I know how many cases of soda I'm buying. Let's say I'm buying 3 cases of soda. Well, how would I figure out how much that would cost me? That can help you set up the equation that you need. So if I'm buying 3 cases of soda, let's say I'm buying 3 cases, so let's say x equals 3, and this is just to help me set up the equation. So let's say x equals 3, buying 3 cases of soda, I'm going to have her $55 membership plus it's $7.50 for each case of soda, and I know I'm buying 3, so it's going to be $55 plus $7.50 times 3. That'll give me the total amount that I'm spending with those 3 cases of soda. So if I'm setting this up so that I am using x instead of 3, I would be putting the x here. So my equation for this becomes $55 plus $7.50 times x, because that's the number of cases of soda, and I don't know, that's what I'm trying to figure out here, but I know that I spent $100. So my equation is going to be equal to 100 because they actually gave me the total. So I'm going to solve this like I've solved the ones in the past. Subtract 55. You want to undo any addition or subtraction first. So 100 minus 55 gives me 45. So I have $7.50x equal to 45. Divide both sides by 750 because the 7.50 is multiplying the x, or 7.5, and I get x equal to 6. Now what does that 6 represent? It represents my number of cases of soda. So 6 cases of soda is my answer. And you can check that solution as I showed you with the first problem. And that ends this session on solving equations.